In January 2026, a series of images emerged from the Chengdu aerospace facilities. They showed the J-20A, China's premier stealth fighter, performing flight trials with the long-awaited WS-15 AME engines. For the casual observer, this was the final checkmate. The Achilles heel of Chinese aviation, its reliance on Russian power plants, was supposedly cured. On paper, China had achieved total indigenous sovereignty over its most advanced weapon system. But for strategic planners in Washington and Tokyo, the photos told a different story. If you look past the airframe and the exhaust nozzles, you find a deep structural paradox. To build that engine, China's industrial base didn't just need blueprints, it needed high-precision 5-axis CNC machine tools, specialized metrology equipment for quality control, and the sub-14-nanometer semiconductors that run the digital twin simulations of its flight envelope. The paradox is this: as Chinese weapons become more sophisticated, they don't move further away from the West, they move closer to it. They become more dependent on a globalized high-end ecosystem that Beijing does not control. We are witnessing the rise of a veneer superpower, a military built on the assumption that the global supply chain, the very system it is designed to challenge, will remain open, updated, and accessible, even as the first shots are fired. Today, we decode the choke point paradox, why the made-in-China arsenal still breathes through Western lungs, and what happens to that metabolism when the air is cut off. To understand why this dependency exists, we have to look past the Made in China 2025 headlines. For a decade, the prevailing narrative has been one of decoupling, the idea that the two largest economies are untangling their nervous systems. But in the defense sector, a different chemistry is at play. Beijing's primary strategy, military-civil fusion, was designed to eliminate the barrier between the shopping mall and the missile silo. The logic was simple. If China is the world's factory for smartphones and electric vehicles, why not use that same commercial engine to build a world-class military? The result is a strange modern contradiction. By pulling its private tech giants into the defense fold, the PLA didn't just inherit domestic innovation, it inherited the global supply chains those companies rely on. When a Chinese shipyard builds a bulk carrier for a European firm and a Type 054 frigate in the same basin, they share more than just water. They share the same high-end precision tools, the same Dutch and Japanese specialized sensors, and the same high-performance lubricants that China's domestic industry still struggles to produce at scale. This creates a central question for the next decade of Indo-Pacific security. If China is currently outbuilding the US Navy by a factor of 3 to 1, but 40% of the sophisticated brains inside those ships rely on components that can be turned off by a desk officer in Washington or Brussels, who actually holds the strategic advantage? We aren't just looking at a gap in parts, we are looking at a gap in industrial metabolism. In peace, China's system is a master of assembly. In war, that same system faces a two-clock problem, the speed at which it loses equipment on the front lines versus the speed at which its high-tech imported stockpiles run dry. For decades, the heart of a Chinese fighter was Russian. Today, Beijing claims the WS-15 engine has finally severed that cord. But in high-end aerospace, sovereignty is a sliding scale. Mastering an engine isn't just about the design, it's about the metallurgy. Modern turbine blades must survive temperatures exceeding their own melting point. To achieve this, China relies on single-crystal superalloys and precision cooling channels, technologies that require specialized 5-axis milling machines. Here is the irony. Many of the machines used to indigenize Chinese engines are themselves products of Japanese or European engineering. According to 2025 industry data, foreign firms still command over 60% of China's high-end machine tool market. For planners in Washington, the insight is clear. China has domestic engines, but it does not yet have a domestic process. If those tools lose access to proprietary software updates or specialized Dutch and Japanese sensors, the longevity of the PLA Air Force starts to decay the moment a conflict begins. 2. The silicon ceiling: precision versus volume. In early 2026, the strategic debate shifted from who has the most missiles to who has the best brains. China can mass-produce legacy chips, the kind that run a toaster or a basic truck. But modern warfare is defined by new quality production forces, AI-driven targeting, quantum sensing, and hypersonic guidance. These require sub-14 nanometer architecture. Despite billions in state funds, China's silicon ceiling remains. While they've stockpiled high-end NVIDIA and specialized FPGA chips, a stockpile is, by definition, an expiring asset. For an Indo-Pacific force posture, this creates a precision floor. China can launch 1,000 missiles, but its ability to sustain a smart war, one that requires constant chip replacement for high-attrition electronics, is tethered to a Western-controlled supply chain that can be throttled at the source. 3. The gray metabolism, the dual-use trap. There is a hidden incentive structure at play. By using military-civil fusion, Beijing effectively turned its entire commercial sector into a defense reserve. On the surface, this looks like a strength. It allows the PLA to hide military procurement inside civilian orders for dual-use tech, everything from drone motors to satellite sensors. But this fusion is a two-edged sword. It embeds global-in vulnerabilities into the very core of the PLA. When you use commercial-grade components to bridge a technological gap, you inherit commercial-grade vulnerabilities. For NATO intelligence, the MCF program isn't just a threat, it's a roadmap. It identifies the exact choke point firms in the global supply chain that, if sanctioned, don't just stop a factory, they stop a military modernization cycle. 4. The two-clock problem, the attrition model. This leads us to the ultimate strategic reality for 2026, the two-clock problem. Clock A is the physical attrition of ships and planes. Clock B is the industrial attrition of the specialized parts needed to build their replacements. China's current model assumes it can win a conflict before Clock B runs out. It relies on a sprint capability. However, if a conflict moves into a sustained war of attrition, a marathon, the PLA faces a catastrophic technical regression. As the high-end Western tools wear out and the chip stockpiles vanish, the quality of what China produces will inevitably drop. In a 6-month war, China might start with 5th-generation capabilities and end with 3rd-generation hardware. Sustainability in the 21st century isn't about how much steel you can melt, it's about how many foreign brains you can keep alive inside your own system. From a strategic distance, China's industrial rise is often presented as a closed-loop success story, a fortress of self-reliance. But the deeper we look into the 2026 data, the more we see what I call the veneer of autarky. Beijing has succeeded in building a world-class military, but it has done so by essentially renting the foundational tools of the West. This isn't a failure of effort, it's a consequence of how modern high-tech systems work. You can copy a stealth airframe, but you cannot copy the 30 years of tacit knowledge required to build the high-precision lithography machines that created sensors. The hard truth for planners in Washington and Brussels is that China is no longer a simple imitator, it is a sophisticated integrator. But here is the logical trap. Integration is not independence. By embedding global commercial technologies into its frontline weapons through military-civil fusion, China has created a military that is functionally inseparable from the very global order it seeks to challenge. For a superpower, this is a dangerous gamble. It means your strategic oxygen is being supplied by your rival's industrial base. In my view, we are entering an era of borrower superpowers. China's current military strength is real, but it is subsidized by a global transparency and trade flow that is inherently fragile. If the logic of the 21st century conflict is sustainability and attrition, then China's greatest vulnerability isn't its lack of soldiers or ships, it's the fact that it has built a high-tech sword using its opponent's hammer. Until China can build the tools that make the tools, its military modernization will remain a high-performance engine running on a finite tank of foreign fuel.
If we look at the 2026 U.S. National Defense Strategy, the language has shifted. It no longer speaks of short, decisive victories. It speaks of prolonged, systemic confrontation. This is where the two-clock problem stops being an academic theory and becomes the primary variable for war in the Indo-Pacific. Clock A is what the public sees. It's the satellite feed of a carrier being struck or a squadron of fighters being shot down. This is the kinetic war. In this arena, China has a massive advantage. It can scale, it can surge, and it can absorb losses that would paralyze a Western democracy. But Clock B is the silent killer. It's the hidden countdown of the industrial metabolism. Every time a Chinese missile is fired, it consumes a specific high-end chip. Every time a jet engine runs for 100 hours, it requires the calibration of a high-precision German or Japanese milling machine. If a conflict breaks out and the global supply chain is severed, Clock B begins to tick towards zero. The strategic insight is this: China is currently a peak performance power, not a sustained precision power. In the first 30 days of a war, the PLA is perhaps the most dangerous force on the planet, armed with the latest sensors and guidance systems that the global market could provide. But in the 6th month of a war, after the stocks of sub-14 nanometer chips are gone and the Western machine tools have lost their software support, China's military production doesn't just slow down, it regresses. It begins to build the 1990s-era versions of its current 21st century weapons. For planners in Washington, the objective is no longer just to win the battle of Clock A, it is to survive until Clock B runs out for the adversary. This is the ultimate second-order consequence of the choke point paradox. Beijing has built a military that can win a sprint, but its industrial nervous system is still designed for a world where its enemies are its suppliers. The greatest threat to the Chinese sword isn't a better shield, it is the simple, quiet reality that the sword cannot be reforged once the forge itself, a global Western-led ecosystem, is closed. The choke point paradox reminds us that in the 21st century, the most critical terrain in any conflict isn't a mountain range or a sea lane. It is the industrial metabolism of the state itself. For decades, we have measured military power by counting what is visible: halls, airframes, and silos. But as we move deeper into 2026, the real measure of a superpower is no longer what it can build, but what it can sustain when the global network is no longer helping it. This leaves us with a question for the next era of defense planning. In a world of borrowed superpowers, does true sovereignty still exist? Or have we reached a point where even the most ambitious state is merely a tenant in a global technological foundation it can never truly own? If you found this decoding of the PLA's incentive structures useful, you may want to explore our previous analysis on the industrial attrition of NATO's deep magazines. Until next time, keep looking past the headlines to the systems beneath. This is Minh Quan Story International.